Hello, everyone. Welcome to this presentation on embedding NimScript for NimConf 2020. My name is Peter Munch-Ellingsen. Most of you probably know me by my IRC handle, pmonk. There is on my website, peterme.net, a full 3-piece article series on this topic. So this will sort of just be condensed short sort of excerpt from that article series. So if you're interested in more of this, you can head over there. There's also examples from that article on GitHub if you want to try and compile and play around with this stuff for yourself. So before we get going, what is NimScript? So NimScript is the subset of Nim that the compiler uses for its metaprogramming stuff, for example, and the compile time execution stuff. So it runs inside a VM in the compiler. And so it's not compiled like normal, regular Nim code. And yeah, as I said, it's used for macros and compile time procedures. But why would we want to embed this runtime Nim sort of scripting language into our compiled Nim projects? So the reason I wanted to do it was because I was writing, or I am writing, a window manager. And for this, I was using TOML as the configuration language. But I very quickly noticed that TOML wasn't really up to the task that I had in mind for it. So, for example, the first thing I did was create a special syntax for doing variables. So I could do like create a variable and then use it somewhere else. But all of that had to be done inside strings because TOML doesn't have like support for that kind of stuff. So I ended up having like parsers on top of the TOML format, and some things like there were a lot of strings just because the syntax wasn't flexible enough. So the benefit of NimScript, of course, first off, we don't have to implement it. The parser, the error checking, all of that stuff is done for us by Nim or NimScript. It also gives users the power to do stuff. So without even us requiring any sort of extra functionality, they can create variables. They can create procedures to do stuff. They can write, like they can share procedures. So take VimScript, for example. So the idea of using a scripting language for configuration isn't anything new. Vim uses VimScript. Emacs has eLisp. And of course, Nimble, as you can see an example of here, also uses NimScript. So this is actually a NimScript code that you see on the screen here. We set a couple of variables. Those are defined in a sort of hidden import that gets added to the script, and requires is just a function that makes sure that Nim is bigger or equal to this version. It's also easy to extend for us. So we can add functionality that otherwise wouldn't be there. So, for example, in TOML, I had to implement my own variables and stuff. In Nim, this could just be, or in NimScript, this could just be a hidden import with code that we write in Nim. And we wouldn't have to parse that out and do all of this weird stuff, but we can just let the NimScript parser do its thing. We can just focus on what stuff does. Of course, Nim has the benefit of DSLs. So we are able to create nice, simple DSLs. This one isn't really a DSL as such, but you can create some really like configuration feeling DSLs that actually does a lot of stuff behind the scenes. Another big thing is, of course, that NimScript is already documented. Since it's Nim, since you can use nim code, it already has a lot of documentation, and people trying to do stuff in this language could look at normal nim resources and see, oh, this is how I can do this, or this is how I can do that. And of course, us as nim developers can use our pre-existing knowledge of nim in order to quickly and easily just do stuff in this configuration language. Another really cool thing, and this is something that was really sort of the nail in the coffin for my window manager stuff, is that we have the possibility to create callbacks. So for example, in i3, which is the window manager I use now, hitting a keyboard shortcut just runs a script, and you have to write everything in bash scripts, which is horrible. First off, you need to like parse a JSON output of like i3 message that is the state of i3 at that moment, figure out what you want to do, and then call commands and all of this in bash, which is horrible. Of course, we could do it in a different language. You can call any kind of program, so we could write it in Python or even in Nim. But here we have the ability to inline have callbacks. And most of the stuff you want to do is so simple that you don't need to have a separate script that does it. We could just say, okay, this is a callback. Here's a list of functions, and here's a list of like state variables. You can use them, you can manipulate them, call this stuff, and you can write a nice callback. So if I hit this key, check that if I have more than one screen, turn one of them off or whatever, like do stuff like that where you're really sort of closer to the state that you're manipulating than you would be in a script, which I find really cool. So how do we do it? How do we go about embedding NimScript into our programs? I first started looking at Nimble, which was the obvious starting point. But it uses what's sort of known as nim-e, which is execute, I believe, which just runs a NimScript file. So it actually just takes your Nimble file, adds the hidden import and some other stuff, and then just runs execute this script file. And what we have in there is all of the stuff that Nimble needs to do. But that wouldn't give us the callback functionality, and sort of not really the use case that we have here. There was also two projects, one by Commodore and one by Sereniter, called Embedded NimScript and Embedded NimScript. They're written quite a long time ago, and they're not really updated. And I started like poking at them and like trying to get them to work on the latest Nim. And I asked around on IRC, and Andreas asked me like, why aren't you not just using the built-in functionality for this? And this was created after these two projects, possibly inspired by them. And this is, it turns out that the Nim in the compiler package now has support for this, called nim-eval. And it allows us to do the stuff that we see here. So we just point it at our standard library. We create an interpreter, and of course give it sort of the files that we want to import into here. And then we can evaluate the script and destroy the interpreter. We can, of course, do a lot more with this. So, for example, if we want to pass data back and forth, this is a bit finicky. So it works well for simple types. But you will have to do stuff like get this, and then similar to how JSON works, you would have to do like get int, get str, stuff like that. And there's no sort of default way to marshal back and forth between the more complex types. So, for example, here, this table that we see here. So here, just to explain, we have no script, just the name for error messages and stuff. We have evaluate the script, that is like this string. And then we get the data out and echo out whatever we get. And that ends up looking like this, which, if you were expecting a table, isn't really what you wanted to see. It's a data object with a sequence of tuples with some numbers and a string and a... Yeah. So this is actually what a table looks like in memory, which is all fine, but it's not exactly what we wanted. I haven't really found like a good way around this for the nim types, but at least we have a really nice JSON module. So what I've been doing so far is just on the NimScript side, convert it to a string of JSON data, and on the nim side, parse that JSON and marshal it back into the same type. And of course, since it's NimScript and since it's nim, we have this sort of we use the same types. So if this was a table, we can convert that to a JSON object, and on the parsing side or the compiled side, we can take that back to a table, and it would be the same table because the types are the same thing. And I'm not sure if it works for absolutely every type, but it should work for like 99% of like complex objects and sequences and all of that stuff. Another thing, as I said, we have callbacks, but we can also implement things in our compiled code, so that our script can call functions from our script can call functions that we have implemented in our compiler. And this is actually something that's done in various parts of NimScript already. So there are some parts that are defined as like just discard or error so when you're compiling for NimScript, and the actual implementation lives in compiled code. So this, of course, gives us a couple of benefits. We can pass in a simple type. We can do complex manipulations instead of passing a complex object in. We can also, or if we don't want to expose everything, we can also do things like optimized stuff. So we can, like, if we have some heavy computation, we can hide that in a compiled procedure that would be faster, and then be able to call that from the NimScript side. So here you see an example of this. So we have a script proc that is just a forward declaration for a procedure that must be implemented in our nim code or in our script code. And then we have compiler proc, which is, as you can see here, implemented in our code on compile time. And here you can see what I was getting at with the data part passing. So here we use the a from arguments, and we get int the zeroth and the first int. This should actually just be the zeroth int because I removed an argument. But what we have, so what this does, the foreign proc selects the routine, which if it isn't implemented in that script file, so script here is just, it's supposed to be a red file. It just couldn't fit more code on the screen. So we select that. If it's not implemented, that would of course throw a NimScript error, expected implementation or something like that. And then we call the routine, and here we can see again we must create an int node to pass in, and it's sort of weird. And then we get the return value, and we need to do the .int val thing to get it back out again. And yeah, so this is sort of how you can call back and forth. It's not the most ergonomic thing, but it works. And as I said, if you need more complex type, just passing stuff in and out as JSON is probably the best bet. I just also want to mention the standard library is not huge. It's 5 megabytes. Compiling in everything you need for NimScript makes your binary about 3 megabytes big. So if you want to like ship this as part of your program, you might want to create like a stripped down version. In the article, I discussed this a bit more. There's a tool for it that takes imports, and you can also add external dependencies. You can, if the license allows, it can then build sort of a library with all the stuff that you use, that you want to use, or allow your users to use out of the box, and then sort of give that to the, or ship that along with it, because there are parts of the standard library that doesn't really do anything in NimScript, so there's no reason for including it. And you might want to throw in some extra stuff as well. But yeah, that was everything from me. It was a short, as I said. On my website, there's a full 3-part series on how to do this. Goes into a lot more detail. And hopefully I've answered your questions in the chat while this has been going on. And you can, of course, always find me on IRC if you have further questions. So that's it for me. Thank you.